measurement and instrumentation costs. And one type of sensor is the so-called tachometer. This is a tachometer. My choice of tachometer is a non-touchable, non-contactable digital tachometer, where it records RPM and RPS, that is revolution per minute and revolution per second. And this tachometer has a various type of tachometer that record analog input and digital input. And there are also tachometer that record in experiment and also in the real outside of industry. Okay. Next, I will present you about the procedure and how to use the tachometer. This is an operate tachometer in this vibration lab. This is a functional tachometer that will record the RPM, RPS of this gear and shaft of this experiment. And first, we have to turn on the experiment, and we adjust the speed control of this rotating shaft. And next, we go to the tachometer and we adjust the laser point to the reflected mark of the shaft. And for the tachometer to take the data of the rotating shaft in RPM or RPS, the laser beam have to be reflected to the shaft and back to the tachometer to read the data. And for doing that, the shaft have to paste the reflective mark using a reflective tape or something that will reflect back the laser. And in this case, it has a reflective tape that will reflect the laser back. And if we rotate the shaft in more fast, the RPM at the tachometer will be increased, and as shown, will be increased at 442 point something RPM, and that data will be transferred to the DZLab software using the national instrument. And this we can see the setup of DZLab of this experiment, where we can calculate the angular velocity of the rotating shaft. And if we run the simulation of the DZLab software, we can easily show the RPM of the omega angular velocity. Okay, and also we can calculate see the variation of graph and chart using the DZLab software that collect the data using the national instrument and back to the laser and the RPM and RPS. The advantage and the disadvantage of this tachometer. The advantage in a tachometer is not contactable to the machine and also easy to operate. But the disadvantage of this tachometer, it has to be run or tested in a low speed experiment, like in this experiment lab, because this tachometer can only read slow speed compared to the high speed of the in the industry. I think that's all for me. Thank you.
Hi, now I'm at a vibration lab. So today I will show you what is a LVDT. Let's go. Okay. Now I show you what is a LVDT. So this is LVDT. For your information, LVDT is to measurement the displacement. So I show you how to use it. Okay, firstly you put the load at the beam. So after you put the load, so you move it. Okay, so the data will be transferred from the DAQ. Then you can see in a Daisy Lab. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahir bin Yunus. My ID number is MA11112. Okay, for the first project that I have to do for the subject measurement is about sensor. Firstly, the sensor that I choose for this project is thermocouple. This is thermocouple. Okay, the thermocouple is a temperature. The thermocouple is a temperature measurement device. Consists of two dissimilar conductors that contact each other at one or more spot. The thermocouple is also produce voltage when the temperature of one of the spot different from the reference temperature at other part of the circuit. Thermocouple is widely used for type of temperature for measurement and control. Thermocouple is also can convert temperature into gradient and then to electricity. For the commercial couple is widely used and inexpensive and can measure a wide range of temperature. That's all for the introduction for the thermocouple. Now I want to show you about how to use the thermocouple. Firstly, we set up the apparatus. We open the apparatus and then we set the temperature. After that, the thermocouple can take the data. The data is transferred into the national instrument, and then national instrument go to the laptop, and then we use the Daisy Lab to get the value of the temperature. The value is we get from the sensor, this and this. From that we can know the temperature at each part of the thermocouple. Okay, that's this is a bit little about how to use the thermocouple. And then lastly, I want to give the advantage of thermocouple. Thermocouple, the advantage is firstly low cost and no maintenance, and second, good accuracy of order, and lastly, excellent stability for a long time period of time. That's all for me. Thank you.
Assalamualaikum and a very good morning. I am Muhammad Nafis bin Nasir, and today I'm at Fluid Mechanics Labs. And in here we have many sensors that we can get, and so let's come and see what sensor we have in there. Okay, now we're here in the Fluid Mechanics Labs. So this is the Pelton turbine experiment. For this experiment, we have three sensors, that is tachometer, strain gauge, and also flow meter. And today I will explain to you about flow meter and how we're gonna use it in this experiment. Okay, this is the flow meter sensor, and we can see here it have a wire that attached to the EQ to get the readings from this sensor, and we can see the result in the DesiLab software. So here the fluid will flow into it, and the result we can see from the DesiLab.
The flow meter that we have in the Fluid Mechanics Labs, known as rotoflow output, it will provide a pulse DC voltage output that is proportional to the rate of flow. When the liquid passes the flow meter, it will spin the rotor and produce magnetic pulse and generate a series of voltage pulse. This will give the readings to the DesiLab software.
Assalamualaikum and selamat sejahtera. Today we use this part of experiment for my measurement instrument project. My device for sensor device is about strain gauge that used in Pelton turbine demonstrator. Okay, I briefly tell about a bit history about this strain gauge. Okay, strain gauge invented by Edward and Bush in 1938. So we proceed to the function for this strain gauge in Pelton turbine demonstrator. Okay, we take this device and put it here. So the connector is connect to where the water flow in the pipe. Okay, when the water flow in the pipe, so this device will detect the pressure of the pipe. So it's connect to the national instrument that we measure in the DesiLab. Okay, in the DesiLab. So the value of pressure in the flow pipe will show in the DesiLab. That's all for the